All right, 7.3, using properties of logarithms. So we're start with the change of base formula. There are two different approaches to this that both get you the right answer. There's whenever you're using base tens, meaning if we have log base a of x, you can just do log of x, log of a. Why is that easy? It's really the easiest way to put any of these types of questions in your calculator. Just do log of x divided by log of a. Because your calculator assumes base 10 if you don't put a base in. So it's really simple to put in. And then there's using base e. So if you log base a of x, you can just do ln of x divided by ln of a. Meaning the numerator always gets the bigger of the number. Okay? The small base goes on your denominator. We'll do some examples here. So here we have log base 5 of 16. So you can write this in two different ways. You can do log of 16 divided by log of 5, or you can do ln of 16 divided by ln of 5. Either way is going to get you the right answer, and that answer is going to be 1.72 approximately. Here are the three properties of logarithms. We have product, quotient, and power. All three of these properties can also be used for the natural logarithm. Okay, so it's the same exact rule for ln, nothing different. So product, we can expand them and make an addition. We can also go from here and make it a single logarithm and make it u times v. Quotient, u divided by v, we can make subtraction, and then we can condense and make it log base a of u over v. Keep in mind when we're condensing these two right here that the bases need to be the same in order for us to be able to condense. If they're different, we can't condense. And then power, so log base a of u to the n, you can bring the n up front. I would recommend pausing this video to write down the three properties. So here we have three different examples where we can use our properties in order to solve. First one here on the left in black. We have log base 4 of 8. I can change this to log base 4 of 4 times 2, right? Because 4 times 2 is 8. And then if I expand it, log base 4 of 4 plus log base 4 of 2. Log base 4 of 4 is 1, so that works out nicely, huh? And also, we can change log base 4 of 2 to 4 to the 1/2. Square root of 4 is 2, right? So if I change it to log base 4 of 4 to the 1/2, we move the 1/2 up front, and once again, we know log base 4 of 4 is 1. So it'll be 1 plus 1/2, which is 3/2. That's that one. Over here, in red, log base 2 of 4 squared plus log base 2 of 3 to the 4th. Bring the 2 up front, and then log base 2 of 4 is 2. And I could bring the 4 up front here and get log base 2 of 3. Log base 2 of 3 does not turn out nicely, unfortunately. But 2 times 2 is 4, so I can simplify it to here. And finally, in blue, division, so that's means subtraction. So ln of 6 minus ln e to the second. Ln of 6 does not turn out to be anything nice. The only thing that would be nice as far as a simple number would be ln of 1, because ln of 1 is 0. So I'm going to keep ln of 6 as so. I'm going to use our exponent rule and bring the 2 up front like we have in the past couple problems, or last problem rather. We did in the first problem too, I guess. Ln of e is 1, and 1 times 2 is just 2, so it would be ln of 6 minus 2 as your final answer. In these problems, we are going to expand the logarithm, okay? So in this case, we have the ln of the third root of x over y. Remember, third root, we need to change these. Let me keep it in the same color so we're not confused. So we'll keep this in blue, and it'll be the ln of x over y to the 1/3 power. So we're going to move that exponent up first. 1/3 ln of x over y, and then from there we're going to expand. So 1/3 parenthesis ln x minus ln y. It's division, so we do subtraction. You can write it like this, or if you want to distribute the 1/3, you can as well. Just it has to be either one of these bottom two ones, okay? Because if you don't put parentheses in it, then the 1/3 is going to look like it's just with the ln x, but it's really with the y as well. So moving on, we have log base 5 of first division symbol we have to do first. Okay, when we see division, that's typically going to be first, unless we have something like over here on the left where we have what would be considered quote unquote parentheses or that big root we take care of first. Log base 5 of x squared minus log base 5 of y squared z cubed. So I can bring that 2 up front here, log base 5 of x, and then I need to expand the other one a little bit more. Yes. Base 5 of z to the third. And then we move the 2 and the 3 up front, and we can also distribute negative both terms if we would like. So minus 2 log base 5 of y, and minus 3 log base 5 of z. And that's the answer. All right, we have 2 examples here. The first one on the left we'll do first. Over here on the right, if you're writing these down, this is a z minus 5. I just ran out of space on here. So what we're condensing, that's the goal of this one. We're condensing logarithmic expressions. So first, when doing these, we need to move our exponents up. Okay. Anytime we see a number multiplied by a logarithm, we're going to fix that. So we have log of x minus log of y squared plus log of z to the third. And then I see the minus sign, I'm like, hey, I can divide. So log of x divided by y squared plus log of z to the third. And then we're condensing. And one more time, we're going to do log of x z to the third over y squared. There we go. We can't condense anymore. The goal is to condense to a single logarithm. We did it. We got to a single logarithm. We're good. We did it. Hooray. Go us. Next. I see that 4 up front, and I'm going to move it to both exponents inside the parentheses. So it would be ln of z to the fourth plus ln of z plus 5 to the fourth minus, and I'm moving that 2 up front too, so ln of, remember it's z minus 5 squared. So plus we multiply, so it would be ln of z to the fourth, z plus 5 to the fourth, minus ln of z minus 5 squared. We have a subtraction sign, so we're still not one logarithm. So ln of z to the fourth times z plus 5 to the fourth over z minus 5 squared. There we go. Got to a single logarithm. Good job. All right. I appreciate you watching, and we'll see you in class. Bye-bye.